Hello and welcome to tribetopper.com.
In this video on important concepts from electrostatics for grade 12. So our topic for this video is Coulomb's law and its vector form. Now let's assume that we have Q1 and Q2 as 2-point charges and say R is the distance between these charges, right? So magnitude is R. So what is the force of interaction between these two charges? So whether they attract or repel each other, they will attract or repel each other with a force which is, we would say, directly proportional to the product of charges. So Coulomb's law is the one which states that the force between two charges, whether attractive or repulsive, is directly proportional to the product of charges, and it is inversely proportional to the square of distance between them. So when we combine these two factors and remove the proportionality sign, we add a constant k here and we say F is equal to k times Q1 Q2 upon R square, where experimentally this k has been determined to be 1 upon 4 pi epsilon naught times Q1 Q2 upon R square. Now that's an expression for Coulomb's law in the vector form, the Coulomb's law in a magnitude form or in the scalar form. Now we are going to derive the Coulomb's law in vector form, because that's an important question generally for 3 marks, to derive Coulomb's law in vector form and hence prove that Coulomb's law also obeys Newton's third law. So let's do that. Now F is equal to k times magnitude of Q1 Q2 by R square is the scalar form. To convert it into the vector form, so let's assume here we have origin, we have taken a reference point O. With respect to this point O, Q1 has a position vector R1 and Q2 charge has a position vector R2. So if R1 and R2 are the position vectors of the charges Q1 and Q2 respectively with respect to the origin, then R21 is a position vector pointing from Q1 to Q2 would be R12, and the one from Q2 towards Q1 would be R21. So they'll be equal and opposite to each other because the magnitude is same, the distance is same, so we have equal vectors but the directions are opposite. Now if we consider F12 is the force exerted on Q1 charge by Q2, that means I would say F12, if I want to write in the vector form, I'll also mention the unit vector. So F12, the force exerted on 1 by 2 would be k times Q1 Q2 as it is because the charges are scalar quantities, upon the unit vector would be the vector R would be R12 square. We have to give it as R12, that's in this direction. The force exerted on 1 by 2 is in this direction. So R12, the force on 1 due to 2 would be in this direction, and suppose it is repelling it. So we have into the unit vector R12. Unit vector is important to specify the direction. So R12 is a unit vector along acting along this radius vector but towards left. Now since R12 unit vector and R21 unit vector, they are equal but opposite, so I'll put a negative sign here. Therefore that means just to convert the suffixes, F21, that is the force exerted on Q2 by Q1, would then be given as k times Q1 Q2 upon R21 square times R21 unit vector, which is of course towards right. So this is R21 unit vector towards right and R21 vector towards right, and the force acting on this is F21 towards right, where like we have considered the similar charges here, so they are repelling each other. So the force on 1 due to 2 is towards left and the force on 2 due to 1 is towards right. They are repelling each other and based on their position vectors. Now if you look at it carefully, everything is same here in F12 and F21 except for the sign. So R12 unit vector and I have R21 unit vector here. So I can replace it by just putting a negative sign. That means I can write that F21 is equal to K Q1 Q2 by r12 square times r12 unit vector, but just put a negative sign in the front. So now I have the Coulomb's law in vector form, and also I have that F12 is equal to minus of F21, which means that Coulomb's law also obeys Newton's third law, that action and reaction are equal and opposite. So the forces exerted by the charges 1 and 2 on each other are equal and opposite. And please remember that these equations are valid for whether the charges are similar or they are opposite, because in any case you would have the same equations. If it's just that for opposite charges the forces would be attractive, and for similar charges the forces would be repulsive, but you get the same equation in the vector form. I hope you find this video helpful.
Please follow us on Instagram, Facebook, and Twitter at tribetopper.com.